REST API. So, what exactly is a REST API? Think of a REST API like a waiter in a restaurant. You, the customer, look at the menu and tell the waiter what you want. The waiter goes to the kitchen, gets your food, and brings it back to you. That's exactly how a REST API works. Your app makes a request. The API goes to the server. The server responds with the data. REST stands for Representational State Transfer. Sounds fancy, but all it really means is a simple and organized way for applications to talk to each other over the internet. REST uses standard HTTP methods, the same ones used when you browse the web. Get to retrieve data, like show me all users. Post to create something new, like add a new user. Put to update existing data, to remove data. Let's say you're building a social media app. When you want to show a user profile, your app sends a GET request to something like api.myapps.com/user/1. And boom, the server sends back the user's profile information in a clean JSON format. Another key idea here is that REST is stateless. That means every request is independent. The server doesn't remember what you asked before. This makes REST extremely scalable. It can handle millions of users without getting confused. And REST is also platform independent. Your web app, Android app, iOS app, or even a smart fridge can all talk to the same REST API. But REST isn't perfect for everything. When you need very strict rules, guaranteed delivery, and enterprise-level reliability, REST might not be enough. That's where SOAP comes in. SOAP API. SOAP stands for Simple Object Access Protocol. And yes, it's one of the oldest API styles still in use today. If REST is like a casual phone call, SOAP is more like a formal legal contract. Every message must follow very strict rules. SOAP messages are written in XML, and they come wrapped in a precise structure, an envelope that contains everything, a header for metadata, a body that holds the actual request or response. One big advantage of SOAP is that it's protocol independent. While it's usually used over HTTP or HTTPS, it can also run on SMTP, TCP, or other protocols. SOAP also has built-in standards for security, error handling, and also transactions. That's why SOAP is still trusted in industries where accuracy and reliability matter more than speed. Banks, healthcare systems, and government services still rely heavily on SOAP. For example, when you transfer money between banks, there's a very good chance a SOAP API is working behind the scenes to make sure everything is secure and correctly processed. SOAP may feel heavy and strict, but when you need enterprise-grade reliability, it's still the go-to choice. Now, let's switch gears to something much faster, gRPC API. Before gRPC, there was RPC. Remote Procedure Call. The idea is simple. Instead of sending raw data, your app directly calls a function on another machine as if it were local. So instead of saying, send data to this endpoint, you say something like, get user 123. Early RPC systems like XML RPC and JSON RPC worked, but they were slow and didn't scale well. That's where gRPC comes in. gRPC is Google's high-performance, modern version of RPC. Think of gRPC as the Formula One race car of API, built for speed and precision. While REST sends text-based JSON, gRPC uses protocol buffers, which compress data into a compact binary format. It's like the difference between mailing a handwritten letter versus zipping all your files and sending them instantly. gRPC also uses HTTP version 2, which allows multiple requests to run over a single connection at the same time. And here's the really powerful part. gRPC supports 4 communication styles. Those are simple request and response, server streaming, client streaming, bidirectional streaming, and where both sides talk in real time. In many real-world systems, gRPC can be 7 to 10 times faster than REST. That's why companies like Netflix, Uber, and high-frequency trading platforms use it behind the scenes. Now, speed is great, but what if you want precise control over the data you receive? So, this is the next, GraphQL API. GraphQL stands for Graph Query Language, and it completely changes how APIs work. Here's the problem with REST. Sometimes it sends too much data. Sometimes it sends too little data. You might only need a user's name and email, but REST sends their entire profile. That's called overfetching. Or you might need data from multiple endpoints just to build one screen. That's underfetching. GraphQL fixes this. With GraphQL, you ask for exactly what you want, nothing more, nothing less. One endpoint, one request, perfect data. You can literally say, give me the username and email, and skip everything else. Another killer feature of GraphQL is real-time subscriptions. Your app can listen for updates and automatically react when data changes. GraphQL is also self-documenting, with a built-in playground where developers can test queries instantly. GitHub's entire API runs on GraphQL, so do companies like Shopify and Pinterest. If you're building modern apps, especially mobile apps, GraphQL gives front-end developers incredible flexibility. But sometimes you don't want to fetch data at all. You want to be notified the moment something happens. That leads to the next types of API, which is Webhook API. Think about traditional APIs like checking your mailbox. You walk outside, open the mailbox, nothing there. You walk back inside, and you repeat this again and again. That's called polling. Webhooks flip this model completely. Instead of you asking, the API calls you. It's like the mailman ringing your doorbell the moment a letter arrives. Here's how it works. You give the service a callback URL. When an event happens, like a payment, a code push, or a form submission, the service sends a post request directly to your app. No polling, no wasted requests, just instant updates. That's why webhooks are often called reverse APIs. GitHub uses webhooks when code is pushed. Shopify uses them when an order is placed. Slack and Discord bots rely on them for real-time reactions. Webhooks are the silent backbone of automation and modern web systems. Now, let's talk about true real-time communication, which leads to the next types of API, WebSocket API. WebSockets are like opening a permanent phone line between your app and the server. Once connected, both sides can talk anytime. No waiting, no repeated requests. It starts with a handshake. Your browser sends a request saying, let's upgrade this connection to WebSocket. The server agrees and the connections, unlike normal HTTP, WebSockets allow the server to push data instantly. Those types of API are perfect for chat apps, stock price updates, online games, and live notifications. You can send text, JSON, or even binary data like images and videos. If you need low latency, real-time updates, WebSockets are a perfect fit. And finally, let's go fully peer-to-peer, which is WebRTC API. WebRTC stands for Web Real-Time Communication. It's not just one API. It's a full framework that enables direct communication between devices. No central server required. That's why WebRTC powers video calls, screen sharing, online gaming, and instant file transfers. Think about your last video call. Your audio and video are sent directly from your device to the other person's device. Behind the scenes, WebRTC handles network traversal, media negotiation, and adaptive bitrate streaming. That means better quality, lower latency, and no server bottlenecks. WebRTC is the backbone of modern video conferencing and real-time collaboration tools. To recap it, every API exists for a reason. REST is simple and universal. SOAP is strict and reliable. gRPC is fast and powerful. GraphQL is flexible and precise. Webhooks push events instantly. WebSockets enable live communication. And WebRTC makes real-time peer-to-peer apps possible. Understanding when to use each one is what separates beginners from real engineers. If this helped you, you know what to do. Like the video, subscribe, and I'll see you in the next one.